Alright YouTube, welcome back to the All-Wright Fab. So, we've got some stuff going on today. I've made some progress since I last saw you. Some of the video footage got corrupted, so apologize for that, but I'll take you through what I've done and where we're at. Time to take some measurements. So getting all this set up, what I would like to do is have this whole panel as one piece. Because it'll eliminate a weld point, and the way that I'm building this, I can do it that way. So that will actually help me out. So what I'm going to do is I got to do some measurements so that I can build this panel in CAD and then have it laser cut and sent to me. So obviously this panel is all distorted and it isn't perfect, right? So that makes it a bit of a challenge. So we'll average our measurements out and then match measurements on both sides of the cab, on the driver's side and the passenger side. But we'll start with the passenger. So I want my panel to tuck up in behind this flange right here, like it is now, except for the major difference is this flange is going to be brought perfectly square once I get this all drilled out. So I want to keep that in the back of my mind. I'm going to square this edge up, and then I'm going to flange the new piece that's constructed here. I'm going to flange it 3/16 of an inch so that this seam and this line sits flush with the panel below it. And then I'm going to weld the entire seam. So I want to build this pan so that I can do that easily. Anywhere there's a factory joint in this pan, I will do the same thing with the relief. So it'll be flanged so that it can all be butt welded afterwards. The step, I'm getting rid of this style of step. Pretty much all these trucks, this is one of the first things to go as far as rust is concerned. So what I'm going to do is I'm going to cut this out and I'm going to replace it with 1/8 of an inch thick checker plate, which will kind of make sense when you see the CAD design. I'll walk through that when you see the CAD design, how it'll all come together. It will also have a center section that is relief cut for some sort of step decoration that will go in there. Before we get into making the patch panels, it's tool time. So I don't have a tool to do the forming, so I have to make one. We're going to make one with this. Look at that. Useful machinery. So you can buy, so what I need is I need a rounded punch for like the air hammer, so that I can form this and form it deep enough to match what's on the floor. You can buy them. They're like $55 for one, or you can buy a flat hammer for $15. So what we're going to do is we're going to take this, we're going to spin it up in the lathe, and we'll round it out to match the profile that we need. Last battery for these, I'll have to remember to get some. The only thing, battery powered digital calipers. Oh, we've got just under an inch. I want to bring that down to 3/4 of an inch. So we'll give it a quick spin, see what we can do. This machine, in case you're curious, I've had a couple of different a couple of different machines. This one and another one from this brand, which is Smithy. They are excellent. You're going to spend up front the purchase price, which isn't unreasonable, and then the machine will pay for itself. That's the nice thing about it, right? So like my other machine, I think I spent $2,500 on it 15 years ago, and that paid for itself and saved machining cost in like a year and a half. And then eventually I bought this machine when we moved out west here just because I wanted something that was a little bit bigger. But works great. All right, it's time to bust out our handy dandy 3D printer. So we're going to design the base plate for the back side of the mold in Onshape or CAD here. Just a quick run through. This is basically set up so that I can do long channels and the short rounded end bits. So you'll see that forming here. And then once that's done, send that over to the 3D printer. That gets processed, set up for thickness and density and everything else, and off to the printer. And then 12 and a half hours later, we rip through multiple layers, and we'll have a finished part. Still going. Just using up the last of kind of ends of my PLA, so no sense in wasting it. So that's why you got all the layers. Should be done shortly. All right, our part is finished in multiple layers of PLA. So we'll rip this off the table. Looks good. It's nice and dense. It's nice and heavy. So this is going to work really well, just because it has the density to kind of hold up to the abuse it's about to take.
Now, I'm not here thinking that I'm a tool and die maker, but I'm not thinking it either. Let's form some panels.
Time to get our mold assembled. So we got to get these holes lined up. I should have done this in CAD, but I kind of thought about it afterwards. So I printed out the top, the clamp piece. Pretty straightforward. And that's been printed with the holes in it. So I will align these two pieces, drill them out so that I can clamp the material in between the support and the mold itself. And then we should be able to form. So let's do some drilling, get some screws figured out to hold all that together. All right, this week we made some progress on the 58. Slow going, right? I'm making all these panels from scratch by hand using rudimentary tools that I have available, right? So I don't have the fancy bending equipment that a lot of professional shops do. All I have is a little bit of know-how and the tenacity to kind of stick with it and do this stuff by hand. So that's what you're going to see. You're going to see how I do it with limited tools, and hopefully you can use that information if you're in a similar situation where you have limited tools and you want to do and pursue a project like this. So a lot of what you saw was just going through the structure and building it out. It's going to take time. Yeah, that's the nature of the business. I'm very particular with the work that I do, even though sometimes I claim to not be. So we are slowly making progress. We're getting there. It's going to take some time. That's just the process. All right. Next on the agenda, I need to start building out the support structure bracket there. So I'm moving it forward to where the subframe bolts into the frame, so that all that support is in the same location and it's reinforced there. It's a good spot. So I'm going to move that bracket. The bracket in question, I'm probably just going to use for layout purposes. I'll steal the holes off this and then cut out some 3/16 plate, get that in there, bolted in, and then I will use probably 1.5 inch round DOM tubing, sweep that out and bend it out into a 90 so that I can begin coming up the structure with that tubing. And so that will then tie into not just the cab structure, but it will tie into the roll cage structure that we're going to add later.
All right, we've got a problem. That's loose, so that's breaking off. It's hard mount, so what I have to do is, you can see how much the roof is sagging in that corner now. And the front structure is all disassembled and being supported by this jack, which is problematic. So I got to square that back up and tack it back in place. And I'll do that, and I'll take you through the process how I'm going to re-square that and make sure that it's all going to be good to go once we get it all back together. Angle finder. So $65. That's good. It's the same. So I'm going to zero this out. Okay. And now we'll mount this to our top rail in the center. So you can see I've got it mounted up here. And then what I'll do is I'll raise this until I get that within the spec that I'm looking for. Which is 0. It's pretty close there. All right. So the tricky bit here is I'm gonna have to clamp it to weld it. Okay, pretty close to our vertical here. Now we got to figure out our horizontal and where that sits. So we'll do that. Luckily, we've got an unmolested cab in the back that I can take some measurements off of, and I will do that right now. All right, looks like we're in place. Let's double check our angles. All right, so we're looking good. We got the cab squared back up. We got our mount back together. So I'll do some double checking when we go to do the final assembly. I'll check all my measurements, make sure everything's good, but this is looking pretty good right now, and it'll give us enough structure to get our step in. I'm gonna finish up on just the odds and ends of that body mount, get that done, and then we'll be on to finishing the floor band on this side, which is a couple more divots, and get it welded in. So I've got all this floor pan. So I've got the one rib done. I got to do this second rib, and then we got to get our hard mount finished up here. So the machine work on that, I've already got the nut side ready to go. So that'll go up through here, and then the body mount bolt will come up through here, this hole here, and screw into the bottom of that round tube end. And then there'll be some round tube structure, which I've got bent already. So this is gonna go up into the A-pillar inside like this, and it'll link up with that, get welded into that bushing. And then that will be the basis for our internal structure that's gonna go into this. So I'm gonna start working on that. Okay, so what we're going to do is we're just going to clean up this coped end now that we've got it kind of sorted out. That was a huge pain in the butt. I'm going to have to put some effort into finding my tubing notcher. No idea where it disappeared to. Anyway, so what we'll do is, it might be on that shelf over there. I'll go take a look for it. All right, so we'll clean this cope up. We'll get it in place. We'll get it tacked in. And then we got to cut some plate to go in behind where you can see here where we've got the 5 holes there, right in the A-pillar. So those will receive bolts that will mount that plate into. So they will mount into that plate. So we gotta build that plate, get that bolted in, and then tack in the support structure here, and then we can finish weld it all and install it. Nice clean fit. That's good.
So this is the panel that we've been working on this week. It looks pretty simple, pretty straightforward, right? It's just a floor pan, but there's actually quite a bit of work that goes into all the details, right? So all the channels that are hammered into this panel, right? That takes a lot of extra work and thought and forming to get those set. And then those, by putting these in, it gives the panel a lot more rigidity, but at the same time also warps the flatness out of it. So then you have to correct that back to flat after you get all these welds done up, right? So that's been done. Couple of compound curves, right? We've got 90-degree bend here on the turn. That was done just in the corner section. That's the only piece that was welded in, and you can see on the back side, this corner section was welded in, the rest was bent in place. This edge, this is the flange that'll meet up with the existing floor structure that's in there now. So that flange is there, and that'll get drilled and spot welded into the cab. And then there's a couple of additional pieces left to do on this floor pan, but I'm hoping to have this done and us moving on to something a little bit different next video. So a couple of ribs that I have to put in here and here to match the existing floor in the truck. And then this panel, I got some rust to take care of on the inner panels and stuff like that. And then this panel could get installed and welded in. So that is, that's how we've done it. Now to take you through that again, so I'm using a 3D printed die, which has a profile on it that matches the profile that existed in the original floor. So I take this die, I lay my sheet over top of it, and then I bolt this upper guide and this die together with the sheet steel in between. And then I use a hammer and a homemade punch, railroad spike, medium carbon steel, good for that kind of thing. And I lay that in there, and I get the initial shape forming with this by hand, mostly because I don't have a big enough air compressor to run the air hammer at full power. So I have to be intermittent with the air hammer, so I use it for the fine tuning. So I get this down, I get the sheet into like a good spot where it's ready to go, and then I take my profiled hammer right there, and I run that inside the guide, and that matches up with the final shape that I want. I'll run this through 3 or 4 times to get it nice and flat, and to get the curvature consistent in these runs. Once that's done, fill, tack weld all the pieces of the panel that had holes in it from where I drilled through it for the forms. So fill those with weld. The best way that I found to do that is use a copper or a brass, in this case, backer, something that isn't going to accept weld of like a steel weld. That'll give you a nice backer, and then you just put that behind the holes, and then you fill in the hole with filler rod as you weld them up. That gives you a fairly smooth back. I went around afterwards and kind of built up the backside, just any little hollows and stuff, just to make sure that the quality is there, because I don't want any voids in this, because that'll trap moisture and everything else, and it will cause me to redo this again in 10 years. Once that's done, a lot of the curvature, a lot of guys don't really talk about how you remove the warp out of the metal once it's there, right? You see them on YouTube, you see them like work the panel, and then all of a sudden the warp's all gone and it's nice and straight again. What are they doing, right? So what you're trying to do, you have to picture the panel. You've got like a stretch. You've got a stretched balloon essentially, right? Each weld tightens sections of that balloon. So think of it as a stretched balloon, and then I've got a ball bearing sitting at various points over that stretched balloon that references a weld point, right? So the gravity and the weight of that draws the steel into that area and tightens it up, right? So what you're trying to do is take those tight areas in the steel that you've created through heat, and it's the contraction of the cooling effect of the steel that draws it all together nice and tight. And so that's what creates those puckers, because all the surrounding area is being pulled into that location. So the best way to deal with it is, after you weld it up, maintain your weld, right? So you'll always have a little bit of buildup on the back side of the weld or the front side of the weld. What you want to do is have one side ground flat, the side that you're going to use and is going to face the platen, or the flat surface that you're going to be using to straighten the panel. That you want ground flat. On the other side, leave the dome, because what you're going to do is you're going to take advantage of this additional material that's here. And what you're going to do is you're going to hammer that out, specifically on these weld spots. And what that's going to do is it's going to push material outwards, kind of relieving some of that tension, right? So that's what you're trying to do in this case. You're trying to work those spots back out and relieving the tension by hammering those spots out. And then that will pull your panel back to semi-straight. And then it's a matter of just finessing it by hand as is required to get that straightness back into it. This panel still isn't 100%. I've still got a little bit in here in this corner weld that I need to work out of it. It's a little too tight in there still. And I need to change the radius of this bend a little bit as well. So I'll do that at the same time as I work that steel. But that's in essence what you're doing. You're just pushing all those areas back out, and you just do it with a hammer. Like flat steel surface like this is perfect, right? Nice flat surface. You got a target that you're shooting for by using something like this. And then you get a hammer and you're just hammering down on the welds specifically, just trying to get them to spread. You can also use an anvil. The anvil works really good, but the advantage to a big flat plate steel table like this is I can lay the panel flat on it, and I can use both of my hands. So I can work the angle of the panel with one hand while I hammer the other with the other. And on an anvil, it tends to be a little bit trickier, just because you don't have the same surface area. But that's essentially how you do it. Any tight radiuses like this, right? So you can hand form these overlapped radiuses and stuff. It is a lot of work, and what ends up happening is you work hard in the steel while you do it, which will create cracking and everything else. So you can do it, and you work it and you anneal it, and then you work it, or it's not a full anneal, it's a normalize, so you normalize it with heat, and you can build it out that way. But it takes way more time to do that than to just cut, bend, and weld in the complex curvature portions. Even with the finish grinding and everything else, it's still way less time. So that's the way I prefer to do it. The welds here on the backside, what you're doing is you're not cutting at the joint. So I'm not putting two flat pieces of steel. So I'm not putting two flat pieces of steel together like this and then welding the joint at the 90. Two reasons for that. There's always a little bit of distortion in your welds. There's always a little bit of pitting in your welds and inconsistency. And you're going to end up, it's hard to curve this without removing too much material to the point where you lose the structural integrity. So the best way, in my opinion, to do it is you preform. So I've got a panel that I'll use for an example here. So if I preform the curve, right? So I formed a curve. Okay, now I can take this, I can set it back on an edge. So say I needed this curve here to go along this edge, right? So I've got my curve. Now what I can do is I can set that so that it sits square and 90, and then I can mark out my panel where I need to remove the existing panel, and then I would slide this panel in and weld it in place, and that way I could have all of the niceness and the cleanness of the profile that I'm looking for in the rounded edge, right? And have my weld offset so that it's easier to clean, it's easier to finish, right? That's the best way, in my opinion, to do it, and it looks nicer in the end too. So, all right. Hopefully, you guys have enjoyed kind of watching the process on this. If you guys have any specific questions about anything I'm doing, feel free to fire it into the comments. Like, I'm responsive. Anything you want to ask, whether it's like specific to the 58, any of it, just fire away, and I'll get back to you. Yeah, this panel's more or less complete. So once it's done and in the truck, I'll give you the overview and how it ended up turning out in the end, and you guys will be able to see that as we move on to other pieces of this project. Thanks for watching.